From the television studio to the television receiver in your living room in a fraction of a second. This is the miracle of television. Let's visit a television station and see what goes on behind the scenes. This is a television studio. Unlike radio studios, it is quite large in order to provide the necessary room for all the scenery and equipment that is needed in television production. The studio has an intricate lighting system allowing any desirable combination of lights to be set up. As in motion picture work, many moods and effects can be created by the technique of lighting. During a studio show, 2 cameras are usually used, and on bigger productions, as many as 4 are often needed. All of the camera operators and floor directors wear headsets over which they receive instructions from the person who is directing the show. Whether there are 2, 3, or 4 cameras used on a program, only one of them is on the air at any one moment. The director is the man who decides which of the cameras to put on the air. He tells the engineer in the control room, and the engineer switches that camera on the air. On each camera is a set of red tally lights. These lights go on when that particular camera is on the air to indicate to the performers which camera to face. This is where the television system starts, the TV camera. The camera has a turret with 4 lenses, and the camera operator can select the desired one from the rear. And this is the heart of the camera, the image orthicon tube. The camera lens focuses an image onto the image plate of the image orthicon tube inside the camera. The image orthicon, along with the other tubes and circuits in the camera, converts this visual image into an electrical impulse. This image is broken down into individual elements by scanning one line at a time. There are 525 horizontal lines in one complete picture, and the camera produces 30 complete pictures per second to give the illusion of motion. Using a test pattern, the camera operator makes linearity adjustments and sets up the camera so that it produces a picture free of distortion. When the camera is properly set up, it is capable of producing pictures of high quality. The image orthicon is mounted on a carriage inside the camera, and focusing is accomplished by moving the tube back and forth in relation to the camera lens. The camera's viewfinder consists of a small picture tube on the screen of which is displayed the actual picture that the camera is taking. The video signal produced by the camera is delivered to the control room by this cable. Now we're in the projection room where all of the motion picture films are run. This is the film camera. The image from the projector is projected directly into the camera and onto the image plate of the camera tube, which in this case is a Vidicon tube rather than an image orthicon. The Vidicon is much smaller than the orthicon, and its characteristics are ideally suited for use in film cameras and also for small portable cameras. This film chain consists of a 16mm projector for running motion picture film and a slide projector for projecting 35mm slides used for station breaks and advertising purposes. Both projectors operate into the same camera by means of a mirror system. The projectors are operated by remote control from the control room. Start, stop, and slide change. Here is one of the latest miracles of television, the videotape recorder. With this recorder, it is possible to record a complete program, video and audio, and play it back immediately as quickly as the tape can be rewound, and the quality is practically as good as a live studio show. When a recording is no longer needed, the tape can be erased and used over again and again. The recorder is a complex piece of equipment, and all of the control circuits and amplifiers necessary for its operation are contained in these 2 racks. This machine records both pictures and sound simultaneously on a magnetic tape that is 2 inches wide. Due to the high range of frequencies involved in a video signal, a great deal of information must be recorded on every inch of this tape, Therefore, a special high-quality tape must be manufactured for video recording. The recording head assembly actually consists of 4 heads located at 90-degree positions around a disc. A powerful synchronous motor turns this assembly at a speed of about 14,400 revolutions per minute as the tape is pulled past it. Signals are fed to and from the heads by slip rings and brushes. A vacuum action holds the tape in intimate contact with the revolving heads as the tape is transported at a speed of 15 inches per second. As a result, the video or picture is recorded in diagonal segments across the width of the tape. The audio or sound and control signals are recorded a moment later by more conventional type heads. The machine will hold a reel of tape large enough to play for an hour and a half. Now we come to the control room, the nerve center of the television studio. Located in these racks are the audio circuits, preamplifiers, line amplifiers, patch panels, and so on. The video circuits involve video amplifiers, distribution amplifiers, stabilizing amplifiers, synchronizing generators, power supplies, and many other necessary circuits. Located along this control desk are all of the camera control units. These control units supply the necessary power, operating voltages, and synchronizing signals to all of the cameras in the studios. The video engineer operates these units, and by remote control from this position, he is able to make adjustments of beam current, target voltage, beam focusing, setup, gain, and others on the cameras in the studios. It is his job to work with the cameramen and keep all of the cameras operating properly and producing good, sharp pictures. On the screen, he is able to see exactly what the camera is producing, and he can also observe an oscilloscope display of the video signal. At this point, we notice that the video signal does not contain any synchronizing pulses. The sync pulses are added later at the switcher. This is the video switcher. The video signals from all of the studio cameras, the film cameras, the videotape recorder, and the network finally come to this one unit known as the video switcher. From this point, any one of these signals is available for transmission at the punch of a button. The engineer who operates the video switcher is directly responsible for pushing the right button at the right time to put the right picture on the air. The monitor directly in front of him in the center shows the final outgoing picture that is being sent to the transmitter. The switcher is capable of performing many of the effects that we see in television, a direct cut from one camera to the next, a fade out to black, a fade in, a dissolve from one camera to the next, and also another effect of superimposing one picture on top of another. In TV studio jargon, this is more commonly called a super. The audio circuits of a television studio are very similar to those of a radio studio, with the exception that more microphone inputs are generally required for TV stations doing a lot of studio productions. The audio engineer is in charge of the audio portion of the program. Through the facilities of the telephone company, the audio and video signals are delivered by cable from the studio to the television transmitter, which is located at a higher elevation if possible in another part of the city. Some stations use a microwave system for the link between studio and transmitter. The television transmitter performs the functions of taking the audio and video signals from the studio and modulating them onto radio frequency carriers and then amplifying them to a high power level in order that they may be radiated into space by the antenna, so that many hundreds of thousands of television receivers may be able to receive the signals. One engineer is required to be on duty here and perform certain functions. the transmitter engineer must see to it that the audio and video signals are fed to the transmitter at the proper amplitude so that the audio and video carriers will be properly modulated. Too much modulation will cause the signal to become badly distorted, and too little will cause the picture to appear weak and washed out on a receiver. A log is maintained, and every half hour certain meter readings must be recorded. Plate voltage, plate current, percentage of total power output, standing wave ratio, and others. A check is also made to be certain that the transmitter is operating within the allowable tolerances of the station's assigned frequency. This also is recorded in the log. Before the audio and video signals are fed to the transmitter itself, they go through various amplifiers, control circuits, and monitoring circuits. A video patch panel is used here so that in the event of equipment failure, the signal can be rerouted to the transmitter. The video signal passes through line amplifiers, isolation, distribution, and stabilizing amplifiers, a phase compensator, and other corrective circuits before finally reaching the transmitter. The video signal is carefully checked at various points along the way to see that everything is operating properly. Using the oscilloscope, we study the horizontal blanking and sync pulse. We measure the duration of the front porch. We see that the rise time of the sync pulse does not exceed 0.25 microseconds. The width of the sync pulse is measured, as is the length of the back porch. Vertical synchronization is a little more complicated. It is checked to see that there are exactly 6 equalizing pulses both before and after the serrated sync pulse. The width of the equalizing pulses and the serrations in the sync pulse are also measured. The transmitter itself is actually 2 transmitters. One section is for audio and one for video. The audio signal is transmitted as frequency modulation, and the video is transmitted as amplitude modulation. A crystal oscillator is used in the exciter stage, followed by a series of multipliers to bring the carrier up to the proper frequency. This is followed by more amplifiers to bring the carrier's power up to a higher level. This amplifier is capable of amplifying the carrier up to a level of 10,000 watts. Following this amplifier, the signal goes to the final amplifier, which is capable of delivering 50,000 watts of power at its output. The final amplifier uses these tubes, each being capable of delivering 10,000 watts. 5 of these tubes are used in the final amplifier connected in a parallel arrangement. From the final amplifier, the signal is fed by means of a heavy coaxial transmission line to the vestigial sideband filters. Finally, the resultant signal is carried up the tower and to the antenna, where it is radiated into space and received by hundreds of thousands of television receivers in people's living rooms all over the countryside. We have been on a tour of a television station, and we have seen the operations of studio cameras, the film projectors, the film cameras in the projection room, the videotape recorder, and some of its fundamentals. We have seen how all of these pieces of equipment are tied together in the control room, which is the nerve center of the television studio. And we have seen the operation of the video switcher. We have touched lightly on the operation of the transmitter and the duties of the transmitter engineer, and how the signal is finally radiated into space, where it is available for reception by your receiver at any time. All of these operations at the studio and transmitter occur in a fraction of a second and appear almost instantaneously as a complete picture on your TV screen. This is the miracle of television.